All right, so hey everybody, my name is Juan Cardenas, and I am working on fake factor studies for the Charged Higgs boson. So you might have heard of the standard Higgs boson and its associated Higgs field that gives elementary particles their mass. But what is the Charged Higgs boson? Well, the charged Higgs is a hypothetical particle very similar to the Higgs boson that, if found, will provide another mechanism by which elementary particles gain their mass, as well as support supersymmetry's Neutralino as a dark matter candidate. So I and the Higgs beyond standard model group here at UTA are looking for the charged Higgs through its decay to a tau and a tau neutrino, where the tau is the heaviest cousin of the electron. And although we don't measure anything about the neutrino because it seldom interacts with anything in the Atlas detector, we do detect remnants of the tau. And in particular, we're looking for instances where it decays to a spray of particles called the jet. But many other particles, such as quarks or gluons, can decay to jets and fake a charged Higgs tau signature. So we call these types of processes background jets. Um, and so we need to understand what makes these background jets different from tau jets, as well as different from each other, if we stand a chance at distinguishing them from a charged Higgs in our data. So the main types of backgrounds that can fake a charged Higgs tau signature are called multi-jet processes and W-jets processes. And what we want to know is, of all the possible charged Higgs tau candidates that we collect, what proportion are multi-jet processes faking a tau, and what proportion are multi-jet processes or are W-jet processes faking a tau? And these proportions are called fake factors. So these fake factors are calculated using a jet variable that is sensitive to each background type, that is the width of the jet cone. But this variable isn't a very reliable way to distinguish between the jet types and can be improved upon by using a deep set neural network. So during my time in the Atlas Tau working group, I developed a deep set neural network that was used to distinguish between tau jets and background jets. But our group found that this network could be repurposed to instead tell the difference between our two types of background jet processes, multi-jet and W-jet. So this network learns to distinguish between types of background jets in a sort of trial and error process where jets of each type are inputted, and it makes a decision as to what kind of jet it is based on the inputted jet characteristics. And each time it's wrong, it makes a correction and continues. And so once the network can accurately determine jets of different kinds, it is then tested on a set of jets that it's never seen before, and each jet is given a score between 0 and 1. And if there is a nice separation in the score distribution, as you can see here, then you can tell the network is doing a good job at classifying. So in my study, I have found there to be a significant potential to improve our fake factor calculations by using a deep set neural network. So once I trained the network on simulation data of jets between energies of 100 GeV and 3000 GeV, that is giga electron volts, I evaluated a test data set where I found there to be a decent amount of separation, as you can see here in figure 5. So this result is exciting because the jet cone width that we use now um, is not a very good variable to distinguish between the jet types at these energies. So you can see this in figure 7 here. This is 103,000. They look pretty much identical, and in lower energies, 45 through 50, you can see it's not very much better. So in conclusion, these preliminary results show that the deep set net, along with the deep set jet scores, have a potential to outperform the current method of distinguishing background jets across a wide range of energies. But further study is needed to show that this network can outperform our current method when we use a more restrictive set of variables to match what we currently have available to us in Atlas data. Thank you.